Hi, this is Charles DiMaggio. Welcome back to Harvard Epidemiology. I want to finish off our discussion of data frames by going through a somewhat non-trivial example of using indexing to work with a data frame. And what I'm going to do in this example is actually bring in some real data from the New York State it's the SPARCS is a statewide program for research cooperative system, something along those lines. But essentially, it is a census of every hospital discharge in New York State. I believe most every state has some form or other of that kind of data. And I obtained some of it, and what I'm going to do is I'm going to bring it into my R workspace, and then I'm going to work with it a little bit to show you how you might use logical vectors to help index a data frame to get it into the format that you would need. So to follow along with this example, you need to get the data frame in, and here's where you get the URL for it. Go to my website here, follow along, link on epidemiology, link on R, go down to data frames over here, and you'll see SPARCS right here. Click on that, and you'll see here this data frame right. Oh, that is a text file. Actually, it's a comma-separated value file, and you could just nab the URL for it. I'm not going to do that right now. What I did was I took the URL and I pasted it in here. And here, just to give you a chance to type this into your own console or text editor, I want you to use a function called read.csv. I haven't introduced it yet, but we'll talk about it, and it should work. Then I want you to type the word file, then an equal sign, and then within quotation marks, that's very important, I want you to tape to paste the full file path that you just copied, including the .csv. Then I want you to write a comma, and I want you to use this little option here, strings as factors equals false. Remember, capitalization is very important. It's lowercase s, then capital uppercase A, uppercase F, strings as factors equal false. That will help address this business of data frames, essentially converting all characters into factors, which I introduced and which we'll talk about more. But take a moment to look at this right here. I want you to just use this. Just copy it and put it into your thing. Once you've done that, what I'm going to say then is, so let me just submit that right here. And I submit it. And once this comes up, what R did is it went to my website. R is really quite incredible. Went to my website, downloaded that file. Again, I'm going to use the structure command, which again is incredibly useful to get an idea of this data frame. And it says it is a data frame of 3,600 observations and 10 variables. Tells me what the variables are here. There's a variable called X. There's a variable called date, age, county, zip code, sex, race, ethnicity, PDX, which stands for primary diagnosis. It tells what kind of variable it is. If I like to be more concrete about it and take a look at some of the observations, the first 6 observations, I can use the head function to do that, and here it is. What I'm going to do now is I want to select out just those observations in this data set that were births in Brooklyn, in New York City. This is New York. Basically, it's a New York City data set to begin with. It might be New York State. I'm not sure. But in any event, so there is this county variable here, right? And I know, and you need to find this out from your data dictionary, that county 58, is it 58? No, 59. County 59 refers to Brooklyn in this particular data set. It has to do with the FIPS code of some kind. So I'm going to write a series of logical statements that will select out all the births in Brooklyn. And I'm going to actually restrict it to just the age, gender, and disposition variable for those things. Now, how would you do that? And this is something that you might actually really need to do. SPARCS data frames are huge, and you need to whittle them down to get them into some sort of manageable format. Well, the first thing I'd say is, okay, I want to actually look at county, no? And I'm going to restrict to just the county that's equivalent to 59. And as I said, you need to first, it's a 2-step process. First, figure out a way to index it so that you're indexing precisely what you want by a logical conditional operator, and then replace it by putting it on the left side. Either replace it or use it to, in this case, we're not going to replace it, we're just going to use it to select. We're going to index by it. So, the logical statement that I need is hospital county, this variable right here, equivalent to the number 59. And it's a straightforward logical expression. Hospital county equivalent to double equal sign 59. If I submit that, I get a bunch of trues and falses. So that actually there's a lot of Brooklyn here, right? A lot of Brooklyn variables in those 3,600. The first few are not, but there's a bunch that are. And what I'm going to do that I haven't done is I'm going to save this vector, this logical vector, as a object, as a vector object called myCounty, by just essentially assigning that logical expression to that name, myCounty, and I do that. If I were to write myCounty, I would get the exact same logical expression. Now, the next thing I want to do is identify all births, and this brings up one small issue that came up in these data, but it's realistic. So I know that V3000 is a birth. It's a normal vaginal delivery. So if I set hospital primary diagnosis equivalent to, I'm not setting it, if I write this logical expression where hospital primary diagnosis is equivalent to V300, and it's a character variable, so it needs to be in quotation marks. If I do that, what I get back is every single one is false. Now, I know that there are some deliveries in this data set. I mean, delivery is actually one of the most common discharge diagnoses in any hospital data set. So there's something going on here that's actually kind of wrong, and I need to figure out what it is. What I can do is, if I know that there's something going on with this variable, and there are things that you could do to examine the variable. In this case, I'm just going to take a quick look at the variable. There are 3,600 observations. It's not too crazy to look at all of them. So let me take a look at all of them. So if I just submit that variable, here's what's going on, right? So here's the variable. What happened is when it was read in, for whatever reason, R introduced spaces, trailing spaces, and things like that happen relatively quickly. Now, there are any number of ways you could work with this. There's a real nice tool in the Plyr package, P-L-Y-R, that will deal with trailing spaces. There are base functions that'll deal with trailing spaces. But for right now, what I'm going to do is I'm just going to accept, for purposes of just going through this quick tutorial, that rather than using this for my logical expression, I need to use something that includes the two spaces. And actually, that'll work fairly well in this instance. If I submit that, all of a sudden now I have some falses and some truths, and I believe that that's closer to the truth. I would be real careful with this data set, but this is just to teach. So now I have a logical expression that will identify all births, and I have a logical expression that will identify all discharges in Brooklyn. And I'm going to put them together as a single logical expression using ampersand to string them along. So it has to. So for a logical expression to be true, for this to return a true, it has to be both in Brooklyn and equivalent to this primary diagnosis. And I'm just going to save that as a single logical expression called myObs for my observation. I do that, and if I were to bring back my obs over here, I get a series of truths and falses. Every time it's true, this is a birth in Brooklyn in my data set. So now I know the observations that I want. This is the row index that I want. I also said that I wanted to just restrict the data set to age, sex, and disposition. So I'm going to create a vector for those variable names. These names I got right from the names in the data set. If I ever forget, I could just use the names variable. Names, and what am I calling it? Hosp, right? For this data set, and the names in the data set are date, age, count, and I could just cut and paste them from here. The quotations are necessary and important, but I just want these three. And I'm going to use that as my index for basically I'm going to put that into my my indexing for the data set I want to retain, so I save that. Now here is where we actually do the work. What I'm going to do now is I'm going to index my original data frame, hospital, which I read in over here, right? I created this data frame right here. I am going to index it. Again, a data frame is like a list that behaves like a matrix, and I'm going to use rows and columns. My rows are my observations, which are based on this logical vector right here, which I created, which itself is based on identifying Brooklyn and births. And then in my columns, which are the variables, I'm going to restrict it to just these named variables right here. I could have put a number in here actually if I wanted to, if I knew the numbers. But I'm going to save that, the results of that, which is going to be a data frame. It's basically this data frame indexed by this information. I'm going to save it as another data frame, and I submit that. Now, if I want to take a look at my new data frame, what I find is that there are 114 observations of 3 variables. I could just take a look at the head command right here, and this is my data frame. That is one example of sort of quickly manipulating data within R using very sort of fundamental base R tools.